Welcome to The Explainer. Today we are looking at a massive, literally mind-bending paradigm shift in how we understand the origin and the very structure of our entire universe. We're going to explore something called foundational substrate theory, or FST for short. And let me tell you, it completely reimagines everything, from the macrocosmos of the Big Bang all the way down to the microscopic rules that hold your own body together. So let's get right into it.
Okay, let's dive into this. We've all been taught the standard story, right? That the universe began from a single, infinitely dense point that just suddenly expanded. But this theory asks a really radical question. What if the Big Bang wasn't a singularity at all? What if, instead, it was a targeted interuniversal collision? Imagine a cosmic car crash, but on a scale we can barely even comprehend. It's a completely different and, frankly, fascinating way to visualize the birth of everything we know.
To really grasp this, we need to put these two ideas side by side. Traditionally, the standard model assumes everything expanded from that one singularity. And honestly, that concept has historically created massive mathematical headaches for physicists. But foundational substrate theory proposes something entirely different. The sources describe the Big Bang as a massive transfer of energy from an adjacent layered universe during a collision. In this entirely new framework, motion is actually considered more fundamental than matter itself.
So, think of the universe like a giant cosmic onion. Based on FST, our effective dimension is actually calculated at 1.9285, not a perfect 3. That means we're actually missing a huge chunk of spatial dimensionality. Why? Well, because we only inhabit one specific layer of this vast layered structure. Notice the center, which is surrounded by inner layers moving slower than light. Then there's our layer, where velocity equals the speed of light, and it's bordered by outer layers moving vastly faster. Because of extreme refractive barriers between these layers, the outer ones are completely invisible to us.
Now you might be wondering, if we're stuck in just one layer, how far away is the next one? The mathematics calculate the boundary thickness to be approximately 3 billion light-years. To put that into perspective, roughly 3 billion light-years away from the very limits of our layer, there is an entirely different universe. It has its own internal structure, and it's totally separated from us by a region of extreme refractive gradients.
And here is where it gets crazy, because this specific cosmic architecture directly builds our physical laws. Let's break down the Big Bang epoch in this model. First, the adjacent layers collide. Bam! Second, a massive transfer of energy occurs across the boundary. And third, which is absolutely crucial, this energy gets perfectly trapped in our layer. How does that happen? It's exactly like when you're underwater in a pool, looking up at the surface. Beyond a certain angle, you don't see out, you just see a reflection of the pool bottom. That is total internal reflection. In FST, energy from the outer layer crossed into ours, but because of those sharp refractive boundaries, the energy couldn't escape back out. It became completely, permanently trapped.
So what exactly is this trapped energy? Well, according to foundational substrate theory, it is the gluon. Now, gluons are the particles that carry the strong nuclear force. They are the literal glue holding quarks together to form protons and neutrons. But FST suggests something mind-blowing. Gluons are not native to our universe. They are alien primordial energy carriers that were transferred from that adjacent universe during the cosmic car crash. And now they are trapped here forever, just bouncing off the refractive walls of our cosmic layer. Meaning the very force holding the atoms in our bodies together is actually the trapped echo of a multiversal collision. No way, right?
Okay, to understand how this theory predicts all of this, we need to zoom way in and look at its microscopic rules. FST is built on a pre-geometric continuous scalar field, and what's truly astonishing here is its absolute efficiency. The standard model of particle physics requires dozens of unexplained parameters to work, but FST? It uses exactly 8 foundational inputs, just 8. Alongside well-known constants like the speed of light and Planck's constant, it introduces one totally unique geometric property called the strain parameter, valued at exactly 0.049937. This represents the intrinsic physical warping of the substrate itself. And from these 8 inputs alone, FST derives all other physical parameters, 0 free parameters.
Which brings us to one of the greatest, most stubborn, unsolved mysteries in physics. I'm talking about the Yang-Mills mass gap. Put on your physics detective hats for a second. The Clay Mathematics Institute actually offers a literal $1 million prize for solving this. In simple terms, quantum chromodynamics works beautifully in practice, but mathematicians haven't been able to formally prove why quarks are always confined and never found alone. They need to prove mathematically that pure Yang-Mills theory has a mass gap, meaning its lowest possible energy state is strictly above zero.
Well, FST provides a direct analytic resolution to this through a mechanism it calls geometric confinement. Remember those alien gluons we talked about? Because they are physically confined by the topological structure of our substrate, literally bouncing off the refractive walls of our universe, they dynamically acquire an effective mass. This physical confinement generates a mass gap strictly greater than zero. It perfectly solves the mass gap problem just by using the natural geometry of our universe's layer.
And because FST doesn't use those messy free parameters we mentioned earlier, it can calculate the exact scale of this strong force confinement. That number? 217 mega-electron volts. The elegance here is just incredible. FST derives this simply by taking the mass of a proton and dividing it by 4.3, which is a very well-established lattice relationship. When you look at what the particle data group has actually measured experimentally for the QCD confinement scale, they get 217 plus or minus 9 MeV. So the theory's mathematical derivation hits the experimental bullseye perfectly.
And this brilliantly illustrates something else. Because of this mass gap, gluons can actually bind together to form particles made entirely of force. These are known as glue balls. The predictive power here is just incredible. For the lightest scalar glue ball, FST mathematically predicts a mass of 1.710 giga-electron volts. And when supercomputers run those massive lattice QCD simulations, they predict exactly 1.710. For the tensor glue ball, FST predicts 2.394, which perfectly matches the lattice simulation yet again. We're looking at 100% agreement between pure geometric derivation on one hand and complex computational simulation on the other.
So what does this all mean? This quote really sums up the core philosophy of this entire framework. The macroscopic interuniversal structure, that massive cosmic collision we started with, directly dictates the microscopic quantum rules holding the atoms in your computer, your desk, and your very body together right now. In FST, geometry is destiny. The geometry determines the physics.
Which leaves us with a truly profound final thought to ponder. If this framework actually holds true, the very nuclear force that keeps our physical reality stable is nothing more than the trapped echo, the alien debris, basically, of a collision between universes. So as we look out into the night sky, we really have to ask ourselves, if our entire universe is just one refractive layer in a giant cosmic onion, what incredible wonders are hiding out there in the outer layers we cannot see? Thank you so much for joining me on this explainer. Keep asking those big questions, and I'll catch you on the next one.